um, variance from data grouped into class intervals. So if the data is already grouped into class intervals, then in the interval 52, 59, 9.9, you have 7 data. In the interval 60 to 69.99 data. So this highlighted, the two columns highlighted in gray will be the ones given to you. And if they give you this and ask you to find the variance and standard deviation, then we can only find approximation, but it'll be a good approximation. It's not going to be far off from the accurate value because our calculation, the statistical calculation methods are designed to find quite accurate value. It's not going to be, it's approximation, but it's not going to be far off from the accurate answer. Anyway, so how do we find the mean? We have to find the mean first and then use it to find variance and standard deviation. So the idea is same as what we discussed before. You need to take the middle point. So to find the middle point, you can either find the length of the interval. This length of the interval is clearly 10, right? 50 to 60. So half of that is 5. Add 5 to the left hand, you get 55. And add 5 to the left hand here, 65. So these are the middle numbers. So you assume that these middle numbers are occurring at this frequency. These are the frequencies. So now our data have come down to individual numbers and frequencies. So now it's like before. You find the FIMI in the next column and add them up. That's 5775. And divide 5775 by 71 to find the variance. And this is, so this is, we're using the formula. I mean, for mean, it's the same formula, whether it's actual data or sample data. But then when it comes to variance, we need to decide whether it is what they want us to do, whether it's a sample or you need to know whether it's sample data or actual data. So if you look at if you read the question, it says a random sample of students. So it's a statewide test, and so they don't have all the students accounted for, only a sample of students. So that means we have to use the formula for sample variance and sample standard deviation. All right, so the mean is 5775 over 71, which is 81.34. And the problem should tell you whether to round it or not. And I didn't write it here, but this problem tells you to round it to the nearest 10th. So 81.3 is your mean. Do not round it to integer, it'll be wrong. You have to round it to 10th or 100th. The problem will usually tell you. So 81.3 is the X bar I have to use. So now mi minus X bar has to be calculated. So these are the data. You subtract these data, you subtract the mean from these data. So each data here minus X bar calculated here. I have all the numbers calculated here. Oops. And so these have to be now squared. So I'm squaring them in the next column. And then I had to multiply them by the frequencies after squaring, because each data is repeated this many times. So I have to multiply them by those. And that's what this column is. And add them up, 16,447.99. And I need to divide that by 70 because this is sample data. For sample data, the formula says you need to divide by 1 less than the actual count. And that gives me 234.97. And standard deviation is square root of that. And that's all there is. Okay, so so the only thing is, a lot of arithmetic work has to be done here. So usually we make it short enough for you, like by giving you like 3 rows instead of 6 rows like this. So, I mean, you have to be tested on this. So problems like this will be in the exams, but I will not make it so long. I'll give you like just 3 rows of data maybe. So this exercise is very much similar to that, but so we don't need to really do that. All right, so we are finished with this. We are moving on. There's only one problem I decided to give you on this. It's too much arithmetic otherwise. Okay, so normal distribution is our last topic. And we already discussed a little bit about that before. And it turned out that it is an applicable statistics. We can, everybody can use it in real life. Basically, it allows you to forecast future. This, whatever we're going to do here, is going to be figuring out probability for something to happen before it happens. We can figure that out if enough information is provided about that activity. We saw in the past that if I toss 2 4-sided dice and write down all the frequencies and probabilities for each outcome. So the value, the X was sum of the faces. This example we did before, I'm just repeating that. If the random variable represents sum of the faces, then sum of the faces to be equal to 2, I have probability 1/16. We calculated this before, and then we drew this histogram. And this was an example of normal histogram that we had before. So this, it has the bell shape, and therefore it's considered to be normal. So most of the things in real life are normal, and that's why if you know that it is normal, then we can figure out the probability for anything to happen in that in whatever that we are discussing, whatever the event we are discussing, we can find the probability for anything to happen. And we're going to learn all that. And after that, you will be actually doing problems of finding probability for different things to happen before they happen. So if an activity can be assumed to follow a normal distribution, then with little information about that activity, we can forecast the probability for the events, for different events in that activity. Let's consider this example of X equal to X, the random variable represents life expectancy of a certain model shoe, a certain shoes, how long it will last. Let's say we are looking at that as our problem of analysis. We're going to analyze that. How long a certain shoe will last. This is a continuous random variable. Now, in this previous example, this was finite, discrete, right? The values are discrete and finite. So that's why the histogram has these thick bars. But if it is continuous, then what happens? It's not, the values are not going to be like 2, 3, and 4. The values are going to be 0.1, 0.2, 0.3, every little number, even 0.15 is going to be there. So for each one of those numbers, we're going to get a bar. So let's look at this random variable, life expectancy of a shoe. That can be, 1 second, that can be 5 years, 4 years, 4.5 years, 4.1 years. So it can be any number in certain range, of course. Maybe 10 years is the maximum, but any number in between 0 years and 10 years is a possible value for this life expectancy. 1 second, 1250. So what happens if I draw the histogram like here? Here the histogram has these thick bars because the value 2 has a bar, value 3 has a bar. Only discrete values were needed to be shown. But if it is continuous random variable, then 0.01, 0.02, all those have to be shown. So here is the histogram. if I draw the histogram for the life expectancy of the shoe, 0.1 is a possible value, 0.15 is a possible value, 0.11 is a possible value. So you have to account for all of those. So what happens? You have these narrow lines representing the bars. Instead of these thick bars here, I have lines, vertical lines representing the height of the bar. So the probability is equal to the height of the bar at each point here. But all the points on this line are going to have a line, vertical line going from them, because it's continuous random variable. Every little value there will be a value of the random variable. So if I actually draw that histogram and join the top of all those vertical lines, I get this kind of curve, the curve looking like this. And that's called the normal curve. Now, we're basically joining the top. Now, if you join the top of these bars also, you can see that it'll be similar curve. But that's a discrete random variable. This one is continuous random variable. So when it is continuous random variable, the entire, all the bars together make up this curve, the top, all the tops of the bars. You remember, still the heights of these bars represent the probability for each value. So this is a histogram of probability. Okay, so let me ask you this question. If I want the probability for the life of this randomly selected shoe of this same brand to be 0.4 or less. 0.4 or less means I have to add up all the vertical lines on the left side of 0.4, right? The probability for the life expectancy to be 0.4 is equal to the line there, the height of this line there. The probability for the life to be 0.35 will be the vertical line there. So basically, really, I have to add up the heights of all these bars on the left side of 0.4. Now, think about that. Those are lines next to each other. They form our entire, you can see that all the lines together form an area. So adding up those vertical lines is the same as the entire area under the curve on the left side of 4. It's the area now. It's adding up the heights of the bars become equal to area. So therefore, probability for, in this box, I'm making that statement. Probability for random variable to be less than or equal to any value equal to area under the curve on the left of A, left of that number. So it comes down to finding area on the left side of any number. That'll give you the probability for the value to be in that range. But we already know that, see, we're going back to this, we know that the vertical heights of these bars represent probability for each data, and those probabilities add up to 1. Already we see that here, they add up to 1. So probabilities, which are same as heights of the bars, always add up to 1. So going back to this histogram, this is also a histogram, but it happens to be a histogram of continuous random variable. So adding up all the bars here will be equal to area under the entire curve, the whole area. And that will be equal to 1. So the entire area under the normal curve is equal to 1. And to find probability for any range, you need to find the area under the normal curve in that range. Okay. Now, also notice that it's kind of symmetric. And so if you take them, go back to this, can you see that the average of these values is approximately 5? If you actually average them, you'll get around 5. The mean is usually in the middle. So this 5 is in the mean in this case, and it's in the middle. So especially when it is symmetric, the mean will fall right in the middle. So the middle number here is the mean. And also, if you remember, median is exactly the middle number, right? Always, after arranging them. These numbers are already arranged. Everything on the x-axis is in order here. So the median is this middle number. Now, think about mode. Can anybody see what the mode will be? The mode is the one that has the largest frequency. The data that has largest frequency is the one that has largest probability. Go back to this picture again. What is the largest probability? Which data has largest probability? The data 5 has the largest probability, 4/16. Because the frequency is 4, frequency divided by total frequency is the probability. So frequency is highest, that's why probability is highest for that data. So probability is highest when the frequency is highest. So therefore, going back to here, which data has the highest frequency? Can you see that? That's the middle one. The middle one has the tallest bar. Sorry about that. Okay. The middle data has the highest probability. You can see that. The probability is equal to height of the bar at any point. So middle point has the highest probability very clearly. You can see in the picture. So therefore, the data, the mode is the middle number that has the highest frequency. So in other words, the mean, median, mode, all of them equal to the middle number. When the histogram is normal and symmetric. It is symmetric in this case, but in real life, they're not always perfectly symmetric. But if it is symmetric, then they all fall into one place. So that's one of the properties I'm describing here. Mean, mode, and median are all equal to the middle number. if it is normal distribution and if it is symmetric. The area under the entire curve is going to be 1. And the curve is symmetric about the vertical line, which is the mean, symmetric about the mean. And so all these different data in real life, if they're normal, they're going to have this pattern. But then they're all different things going on. So like, if you're talking about how many passengers are there in each car of the train, if you're analyzing that, yes, you do get a largest number in the middle and lower number in the edge. But if you look at another data, like the grade distribution in the class, yes, my middle number, like 60, 70 will have the largest frequency, and the lower numbers, 20s and 30s have low frequency, and large numbers, 90, 95, also have low frequency. So they're normal. But each one, if you draw the graph, one normal curve can be like this, and another one can be like this. So they're both normal, but they have different shape. Another one can be really flat like that. So within normal curve, there are different variations. So if you know it's normal, you need some additional information to know which kind of curve we have. And those additional information are standard deviation and the mean. So you need mean to, you can always figure out the mean if they give you the, from the information they give you. So the standard deviation measures how spread the data is. If the data is widespread, then your normal curve is going to be like this. If it is narrow, if the spread is narrow, it's going to be like this. So that's what determines how wide your curve is. And so that information we need, the standard deviation. If you have the standard deviation, then already the statisticians have worked out the numbers, the area under the curve from any number to any other number. They have already worked out. And so here are some of those numbers I'm going to describe. The area under the normal curve between mu and mu minus sigma is equal to this. It's already calculated. So no matter what the sigma is, between mu and 1 sigma lower than mu, in that region, it's always this much area is there, 0.34 to 135. And because of the symmetry, the area on the right side, which means between mu and mu plus sigma, will be the same because it's symmetric, right? So on left side of mu and the right side of mu, if you go 1 sigma over, the area is the same. So that means if I want the area between mu minus sigma and the mu plus sigma, then I can just double the area on one side. I can calculate the area on one side and double it to get the total area. Now, another fact is from mu to mu plus 2 sigma, if you go mu plus 2 sigma to the right, the area under the curve is 0.47725. And also, if you go to the left, from mu to mu minus 2 sigma, same area because of the symmetry. So if you want to get area between mu minus 2 sigma and mu plus 2 sigma, just double one of them. Okay, so these all these numbers are already known, and they are given in a table, and we are going to learn to use the table to figure out these areas. The areas are equal to the probabilities, and so we can calculate the probabilities by using the table. Okay, so let's do a simple example first. Random variable X represents grades of students in a 15-point quiz, and it is known to be distributed normally and with the standard deviation 3. So based on the past information, they can calculate the standard deviation, and now they can tell you, okay, for this class, for Math 108, this first quiz has this standard deviation from the past information. So can you guess how many students in the next Math 108 class are expected to have a grade between 7 and 10? We can calculate that. So that's what we're going to see. So this quiz, students have the grades of students in this quiz has a mean of 7, average, and standard deviation 3. That's the information given to you. With that, we can find all kinds of information. So here's the first question. What is the area under the normal curve between 7 and 10? 7 and 10 would be 1 sigma over, right? From 7 to 10 is 1 sigma over to the right. So when you go from mean to 1 sigma over to the right, we already know that would be equal to 0.341, this number right here. So that's the area under the curve for that. So therefore, that's also equal to the probability for the grade to be between 7 and 10. So what is the probability that a randomly selected student's grade is going to fall in the range 7 to 10? That's equal to 0.34135. We already have that. If I go to the left, 1 sigma is the standard deviation. If I go 1 sigma over to the left from 7, that'll be 4. So between 4 and 7, what is the probability that the student's grade, randomly selected student's grade, will be between 4 and 7? The same probability, 0.34135. If a student is randomly selected, then what is the probability that his or her grade will be in the range 4 to 10? Can you answer that? Or tell me what to do to get that.
Would we multiply 0.34135 by 2?
Exactly. Very good. 0.34135 times 2, because that's what they are. Both sides are equal. 4 to 7 and 7 to 10 have equal probability, so you just double one of those to get that answer. Okay, so that probability is approximately 0.68, right? 0.68. All right. Now, if there are 30 students in the class next semester, how many are expected to get grade between 4 to 10? What do I do?
Would it be the same answer as C?
That would be probability. Now the question, the probability is correct. 2 times 0.34135, which is approximately 0.68. So for the probability for the student to get grade between 4 and 10 is 0.68. We already found it in part C. But here in part D, if there are 30 students signed up for the class next semester, how many students are expected to get grade between 4 and 10? Now they're asking for the number of students.
Do we have to multiply it with the probability that we found earlier?
Right. Multiply the probability by the total count. Remember, expected value is equal to total count, the probability times total count. That's exactly the question here. So that's right, you got it. We multiply 0.68, which is what we found in part C, by 30. 0.68 times 30 will give you the number. So 0.68 times 30, let me multiply that in the calculator. 0.68 times 30 is 20. So that means, before even the class started, I can say that 20 students in my next 108 class will get grade between 4 and 10. This is accurate. This is because we know that always the grades are distributed normally. So using the past information, we can forecast the future. That's basically what's going on here. So I can tell.
Excuse me, Professor.
Yeah.
So we multiply point
68.
the 0.34135 times 2, and then we multiplied it by 30.
Yes.
Okay.
0.3415 was the area on.
Also, Professor, will we include the decimals or do we just include the 20?
Oh, yeah, the 20.4, approximately, you need to take the whole number because the number of students is expected to be a whole number, right?
So we would just write 20, right?
Yes, you just write 20.
Okay.
Unless the problem tells you otherwise. So 20, I came up 20.4, which is rounded number, which means rounded number is 20, and that's my answer. Okay, so what's the area under the curve between 10 and 13? What do I do to get that answer? Now, remember, 7 to 10 is 1 sigma over, right? 10 to 13 is another sigma over. And we already have numbers for those areas. So can anybody tell me what math I have to do to answer this question? The question is, what is the area under the curve between 10 and 13?
Wouldn't the area be the same as between 7 and 10?
Between area 7 and 10, the area between 7 and 10 is not equal to area between 10 and 13. You can see in the picture, right? They're not equal. Okay.
We have to subtract the area between 7 and 13 from the area between 7 and 10, from the area of 7 and 13. And it would be like 0.47725 minus 0.34135.
Right. You got it. Very good. Excellent. That is correct. We already know that from up here, from mu to mu plus sigma, the area is 0.34135. Mu to mu plus 2 sigma is 0.47725. So to find area between mu plus sigma and mu plus 2 sigma in that narrow range, so let me put it on the board. So we, oops, sorry. Okay, so I'm drawing on the board here. This is my normal curve, and this is the mu, always middle, and mu plus sigma is right here. Mu plus 2 sigma is here. And so the area between these two is the question. Now, area between mu and mu plus 2 sigma, that's given to us as 0.47725. And area between mu and mu plus 1 sigma is equal to 0.3145. 34135. So,
So, Professor, how do we declare which one are I don't know, the numbers
yeah,
for each side? How do we declare that?
no, those numbers are given to you. No matter what the mu, what the sigma are, mu and sigma will be different for different things going on in life. So whatever they are, between mu and mu plus sigma, always the area is 0.34135. That's given to you.
That's what I'm asking. Looking at the graph or looking at the
No, it's been
arch?
already calculated. It's been calculated by mathematician. You don't know how to calculate the area under a curve. It requires advanced calculus, but it's been calculated and it's given to you to use. Okay, so the area is equal to 0.34135 between mu and mu plus sigma, or between mu and mu minus sigma. Okay, we're going to use.
Yeah, I was just asking, those numbers would basically go to the numbers that are below 7, including 7 or below 7.
Oh, you're referring to this problem, exercise 1. Okay.
Yeah, just like when you're looking at the image and the numbers, I want to know where those numbers go.
Okay, all right. The problem here tells you the mean is 7 and the standard deviation is 3. Okay, so that means in the normal curve, if you draw the normal curve for this particular quiz grade, it's going to be like the one I'm showing in this picture here. The mean is going to be the middle, so 7 is in the middle. Okay, and mu plus sigma is 10. 7 plus 3, 10. Are you following me?
Yes.
Okay, so the area between 7 and 10 is same as area between mu and mu plus 1 sigma, which is equal to 0.34135.
Okay. And then now where does the number 0.47725 come from?
That's given to you as the area between mu and mu plus 2 sigma in any normal curve.
So that would just mean in between 7 and 9
13.
instead of it. See, that's what I'm confused about.
7 is the mean. 7 plus 3 is same as mu plus 1 sigma, that's 10. And if you add another sigma equal to 3 here, then you get 13.
And how does that number change from 0.34135 and then goes into 0.47725?
Okay, always in any normal curve, between the mean and mean plus 1 sigma, the area will be 0.34135. So that means in this range, between 7 and 10, the area under the normal curve is equal to 0.34135. Okay? Are you with me so far?
Yes. Then how does it change in between 10 and 13 to be 0.47725?
No, 47725 is not for 10 and 13, it's for 7 to 13. From mean to mean plus 2 sigma is same as 7 to 13.
So, okay, so plus 2 sigma basically is like multiplying or like combining those two groups.
Times sigmas.
Yeah, I was just getting confused because I know 2 plus 7 isn't 13. So I was just confused.
7 plus 3 is 10.
Yes.
7 plus 2 times 3 is 13. 2 sigmas. 7 plus 3 is same as 10, which is what mu plus sigma is. Okay? Mu plus 1 sigma is 10. Mu plus 2 sigma for this distribution, which is the great distribution, is 7 plus 2 times 3. 2 standard deviations added to 7. Okay, that's 13.
Okay.
All right. Okay, maybe I should have said all that before. All right, so between 7 and 13, our area is 0.47725. Understand that?
Yes.
Okay. And between 7 and 10, the area was 0.34135. So if I subtract 0.34135 from 0.47725, that'll give me the area between 10 and 13. Got that?
Yeah. Yes.
All right. See, between mu and mu plus 2 sigma, this whole region is equal to 0.47725. Between mu and 1 sigma, this region is equal to 0.34135. If I subtract, I'll get this. Are you with me?
Yes.
All right, good. So that's how we calculate all these probabilities that we need. So let's go on to,
Professor,
yeah.
I subtracted 0.47725 minus 0.34135, and I got like 0.1359.
Yeah, that's the
But
area. That's the area between mu.
that's the answer for the question.
That's the answer for the question.
Okay.
All right. So that's how we calculate all these different areas, by adding and subtracting, things like that. Okay, so let's go to, that's enough, we don't need the exercise 2. Let's go to the normal distribution table. Now, all these areas have been calculated. Now, I just mentioned the area between mu and 1, mu plus sigma, and mu plus 2 sigma. Not only those, mu plus any number of sigmas, if you go over to the right or to the left, all the areas have been calculated. So mu plus 0.1 sigma, mu plus 0.15 sigmas, everything. So there's a table available already, and using that table, we can figure out the area for any distribution. Any distribution, we can find the area between any number and any number. Here is how the table works. If you want to find the area between mu and mu plus 1 sigma, the table is organized by the number of sigmas that you need to go over to the right to get to the number. For any number under the normal curve, if you want to find the probability between mu and that number, you need to figure out how many sigmas over that you need to go to get to that number. So if it is mu plus 1 sigma, then you look up 1, number 1 in the table. If it is between mu and mu plus 2 sigma, in the table, you look up the 2. The 2, that number is important to us. So if it is between mu and mu plus 1 plus 2, 3 sigmas, you have to go over to get to that specific number you're trying to get to. Then 1.23 is the number you look up. So in other words, no matter what number they give you, you have to calculate how many sigmas you need to go from mean to get to that number. That's the key number you need to figure out. So I'm going to explain how to do that. So let's say I'm given in a problem, I'm writing on the board, they say mu equal to 5 and sigma equal to something like 1.3. Sigma is always a fractional number. And then they ask you, okay, find area between 5 and 6.9. So this kind of question we need to answer. Find the area under the normal curve between 5 and 6.9. Then I had to figure out 6.9 is how many sigmas away from 5. That's what I need to figure out. Okay, so that means 5 plus n sigma equal to 6.9 mathematically, if you want to find it, this is that you will write, right? So I'm going to write that in a more general format. Mu plus, without using the numbers, mu plus n sigma equal to the given number. The given number is, let's say, k, whatever the given number is. Then what I need to figure out is n. How many sigmas from mu I have to go to get to the k? So I'm going to mathematically solve this equation for n. You subtract the mu from both sides, so n sigma equal to k. Let me call that x instead, the value of the random variable. So x, I'm subtracting mu from both sides, so x minus mu. And now I have to divide by the sigma to get the n. So n equal to x minus mu over sigma. So this is the formula we have to use. Whatever the data they give you, subtract the mu and divide by sigma to figure out how many sigmas away that data is from the mean. And so the number you calculate this way is called the z-score. The z-score is given by x, the number they give you, minus mu over sigma. So simply have to use this formula to figure out the z. And what is the meaning of the z-score? That's how many sigmas away your data is from the mean. That's what this number represents. And if you calculate that number, then you can look up on the table. The table gives you the area between mean and that number. It always gives you area between mean and that number. That's all it's going to give you. If you need any other numbers, you have to do your math. So let's look at a simple question. It says in the normal distribution with mu equal to 2, mean equal to 2 and sigma equal to 1.2, the value 3.8 is how many sigma away from mean. That's same as the z-score. Basically, we need to find the z-score. Okay, so let's find the z-score for this. The z-score equal to x minus mu over sigma and equal to, in this case, x is 3.8. The data is 3.8, and we need to figure out how many sigmas away 3.8 is from the mean. So you subtract the mean, which is in this case 2, and divide by the sigma, which is 1.2. And so that's equal to 1.8 over 1.2. And put that in the calculator, 1.8 divided by 1.2. And I'm getting 1.5. So that means it is 1.5 sigmas away from the mean. That's what it means. So this number 3.8 is 1.5 sigma away from the mean. That number is needed for us to look up on the table. So I'm going to show you how to look up the table now. Here's the table. And that table is the same. It gives you the area under the normal curve from mean to any number. So for example, here, in this problem, I want to find the area between the mean and 3.8. Okay, then I calculate the z-score for 3.8, and that came up 1.5. So in the table, I can look up the 1.5. Here's how you look up. The z is the first column here, and our number is 1.5. So I have to go down to 1.50. The first column is 0. That gives me the area, 0.4332. Everybody see that? 0.4332 is my answer. Go under 1.5 in the z column and go to 0 column. Now, what are these other numbers here for? Let's say I want to find the area for the z-score of 1.53. For this z-score, what I do is go to the z column, go down to 1.5, and go over to the column 0.03. This number right here, 0.4370. I cannot highlight it. 0.4370 is the number. So that these columns represent the 100th digit in your number, in your z-score. So I have a 3 as my 100th digit, so I have to go to the column that shows 0.03. So 1.53, the probability or the area under the normal curve between mean and 1.53 is equal to 0.4370. Right there, that's our probability. That's the area. Area is same as probability. All right. Feel free to interrupt me if you're not following anything. So if I want to find the area under my normal curve between mean and 1.53, then I can look up the table.
Professor,
Yeah,
why are we looking up? Where did we get the 1.53 from?
I made that up. Instead of 1.5, if the z-score is 1.53, I wanted to show you how to look for that in the table.
Oh, okay, thank you.
So you had to first find the z-score for the given problem, and then look up the table for that number. So if the z-score is 1.53, then I showed you how to look up. Go to 1.5 on the z column.
Yeah, and then go to the 0.03.
Right. So just to show you, I made that number up. Okay, so now we know how to look up the area under the curve. Now remember, the area under the curve is same as the probability. So therefore, if the question says, what is the probability, going back to this question, if this problem says, what is the probability for the value to be in the area, in the range 2 to 3.8. 2 is the mean, 3.8 is on the right side of mean. So from 2 to 3.8, for the data to fall into the range 2 to 3.8, what is the probability? That is equal to the area under the curve between those two numbers. And that's what we looked up. That probability is equal to, our z-score was 1.5, so the probability is 0.4332. The area under the curve is equal to probability. Okay, so let's go to exercise 6. In a normal distribution, mu equal to 3, standard deviation 0.8. Find the area under the curve on the right of 3.992. All right, so let's do those problems now. On the right of 3.992. Okay, so exercise 6, part A, the value of x, the data is 3.992. So first I have to figure out what the z is. And also on the normal curve, you need to figure out where it is. So drawing the normal curve on the side is helpful. The mean is here. What is the mean? 3. So 3 is here. So 3.992 is on the right side. And so somewhere here, you can mark that there. And to be able to figure out the area between 3 and 3.992, that's the only area we can figure out from the table. To do that, I need the z-score for that. So you figure out the z-score, 3.992 minus the mean, which is 3. And then you divide by sigma, which is 0.8. This will tell you how many sigmas away that number is. Okay, so I'm doing that I'm doing that in the calculator. So I get 0.992 divided by 0.8. And I'm getting 1.24. So my z-score is 1.24. This is called the z-score. So 1.24. Now I can look up the area, look up the table, but the table will give me only the area between mean and this number. All right, so let's look that up, 1.24. Go back to the table. 1.2 here and over
Excuse
to.
me, Professor.
Yeah,
So what you're saying is when we work out this, the answer that we get is the area, is the I mean the mean, and we have to look to the table to find the area.
yeah. You find the z-score like I did here,
Uh-huh.
and then you look up the table. That'll give you area between three,
So
three,
so um
3.992. It'll only give you area from the mean to that number.
okay, so and then when we use the Weber sign, we're supposed to put the number that we find in the table for the answer.
If the question is just the area, yes, but the question can be different. Okay.
Okay.
Yeah.
And on the exam we'll be able to use this table.
Yes, you will be able to use this table. You have it in the, you can print this entire worksheet, right? Then you have the table. And it's also in your book. The table is in your book, but you're not required to have the book. So you can print this and use it. When it comes to test, I had to give you this. I'll give you that somehow. Okay. If you want, I can email that separately so that you can print it. Just that table. So you need this table, yes. So let me finish this problem. So I found this z-score for 3.992 as 1.24. So now I'm going to look up 1.24, and 1.24 gives me the number 0.3925. So 0.3925 is this section, 925. That area is only this. But the problem is not asking for that. It's asking for area on the right side of this. So let me explain something now. Another fact about the normal distribution is the entire area is equal to what? Entire area under the normal curve equal to what?
1.
1.
1.
Yes. And the mean is always in the middle. So can you see that the mean is dividing the whole thing into two halves, right? So what do you think?
0.5 on each side.
0.5 on each side, exactly. So the entire, under the normal curve, on the right side of mean, you have 0.5. On the left side of mean, you have 0.5, always. So can you now tell me how to find this area here?
We
The
would
area?
subtract the 0.925 by 5.
Subtract
0.5.
the, subtract the one we looked at, 0.3925 from 0.5. Yes, right, from 0.5. The whole region on the right side is 0.5. So if I subtract 0.5 minus 0.3925, that'll give me the area on the right side, which is this.
How do we get 0.3925?
By looking up at the table. Uh, the number was given to us as 3.992, right?
Oh, I thought you got 1.22, that's why.
No, the z-score was 1.24.
Okay, I see it. Sorry.
Mhm. So I found z-score 1.24. I looked up the z-score, and that gave me 0.935, 0.3925. And that is the area from mean to 3.992. The table only gives you area from mean to that number. So using that number, I have to find the answer I need. The answer I need is area on the right side of 0.3992. To find that, I need to subtract this from 0.5. Okay. Uh, so let me now do the second part. On the left of 0.3992, part B says, what's the area on the left of 0.3992? Okay, that means this entire area. Now, let me draw that in the picture. So the area we are looking to find is this is 0.3992, and the area we need is all of the left side. Okay, we already have found the area between mean and this number as 0.3925. What do I have to do to answer this question?
Add 0.5 and
I'm going to-
0.3925.
Right, add 0.5 to the 0.3925 because the entire left side equal to 0.5. So just add that and you get the answer. Okay, and now let's go to next question quickly. Part C says, what's the area between 3 and 2.324? 2.324 is clearly on the left side of 3, right? It's lower than 3, so it's on the left side. So I'm going to show you how to figure out the area for that. You find the z-score equal to 2.324 minus 3 over 1.2. 1.2 is the sigma. So that's going to become a negative number. 2.324 minus 3.
How did we get 1.2 as a sigma?
1.2 is the sigma given to you, the problem. Oh, I'm sorry, 0.8. I'm looking at the wrong problem.
Yeah, I was confused too.
0.8. I was reading the wrong problem. So I'm subtracting 3 from that and now dividing by 0.8. Divide 0.8 and I'm getting negative 0.845. All right, what does that mean? This means from mean, I have to go to the left 0.845, right, sigma. This many sigmas, I have to go to the left of 3. Now, remember, the whole thing is symmetric. So going so much to the left is same as going so much to the right. The area is the same, isn't it? Agreed? Area is same on both sides. So when you get negative 0.845 as the z-score, you can just look up the 0.845 because area on the left is equal to area on the right, going the same distance. So going back to the table, I need to look up 0.845. I had to round it to the nearest 2 digits. This is equal to negative 0.85, rounded number. And so 0.85 is 0.0 and then over to, 0.8 is right here. And then go over to 0.05 and the number is 0.3023. So the answer is 0.85. I forgot 0.85 right there. 0.3023. 3023. That's the area between 3 and 2 point, that number given to us, 2 point whatever. Okay, so we answered this question, part C. One part left, I'll finish that quickly. Between 2.324 and 3.863, what is the area? So let's go to that. Let's put that on the board here. So my normal curve is like this now. And so only if you mark these numbers, these things will be easier. This number 2.324 is on the left. 2.324 is on the left. And the area between mean and this, we already found. This area is equal to this number. We just found it by looking up. And then between 0 and 3. Between the mean and 3.863. 3.863 is somewhere here. 863. Okay, so to find the area between mean and that, I need to find the z-score. Z-score equal to 3.863 minus 3. Mean is 3 divided by 0.8. And so I'm going to calculate that, 0.863. 0.863 divided by 0.8. is 1.078. I'm getting 1.078. I have to round it to 2 fractional digits. So 1.08 is what I'm getting. So look up the table for 1.08 and I get 1.0, go over to 8, I get 0.3599. So 0.3599 is the area from mean to this number, 0.3599. Okay, so what do I do to answer the question?
Add 0.3023 plus the one that we just found right
Right,
now.
add those numbers. This area is equal to 0.3599. This area equal to 0.3023. And you just have to add them to find the area between those two numbers. Okay, so the answer is, let me quickly finish this problem. 0.3023, 0.3023 plus 0.3599, 0.3599 equal to 0.6625. So the answer to the part C is 0.6625. Okay, now the question can be different. Now the question can say, instead of talking about area, the question can say, what is the probability that the random variable is between 2.324 and 3.863? The area for the random variable to be between this and this, is the same as this area, entire area. And that's what we just found. So 0.6625 is your answer for that question also. Sometimes the question will be asked differently. What percentage of the area under the normal curve is between those two? So between these two, the area between these two is a percentage. What percentage of the entire area? Well, the probability is same as percentage, remember? So the 0.66 is the probability, means 66%, 66.25% is the percentage equivalent of this probability number. You just multiply by 100, that gives you percentage form of the probability. So this is the probability, means 66% of the entire area is 1, right? So the probability for this region is 0.66. 66% means 66% of the entire area is right here. So the percentage question, the answer is the same as the probability, but you had to answer it with the percentage form. Multiply by 100, that's your answer. If they ask you what percentage of the area is in this range. So the questions can be different, but the answer can be found by looking up the table.
Professor, can you
Yeah.
explain how you got 0.6625 again?
By adding these two numbers, the areas we found here, we found this area to be equal to 0.3023. And this area is 0.3594.
So you just add that up?
Add that up to get the total area.
Okay, I got it.
Yeah. So basically what I did was, to answer this question, last question, 2.324 is on the left side. 3.863 is on the right side of mu. So find the z-score for both of them. And by looking up them in the table, you can find the area between mean and this, and mean and this, two separate things. And after that, you add them up to get the total area. Now I'm adding them up because from the picture, I can see that one is on the left side, one is on the right side. So that means I add up to get the area that they're asking for. So what if they ask for an area like this? Let me ask you a quick question. And this is mean. And they give you like, okay, this is mean is 3, and this is 3.2, and this is 3.5. I need the area between those. So the question says, what is the probability for the random variable to be between 3.2 and 3.5? This. Okay, just tell me what to do. Anybody? This area is what I need. Okay, let me explain. I find the z-score of this number and look
Then
up,
you would add them together, right?
no, if I find z-score of this number and look up in the table, that'll give me area from mean to that number, this whole area. Agree?
Yes.
Then I find the z-score of this number and look up in the table. That'll give me area from mean to that number, which is this. What do I do with them?
Do you subtract them?
Subtract them, exactly, to get the area they're asking for.
This is
So,
for letter D?
no, I just made that up.
No, but this is what we would do for letter D?
No, the letter D was different. The letter,
Okay.
the numbers were on two opposite sides.
Okay, no problem. I was just
Yeah,
confused.
the letter D had one number on the left side of mu, the other number on the right side of mu. So if I look up the left side number, I get this area. The right side number will give you this area. I needed to add them up for part D. In this problem, I just made up this one separately. If they give you a number on the right side and another number on the further right side and ask you to find area between those two, then you have to do this. You find the area from mean to this and mean to this, subtract, right? To get that part. It wasn't in the problem. I just made that up because you need to do that in your homework. All right, so that covers all of that. This additional exercise, we don't have the time for. So we'll quit here. This assignment, there's assignment on this, and that's due next class. And we can go over these problems in the next class, and I can go over the practice test problems also in the next class. So next class is pretty much going to be discussion. But if you need,
So, Professor, the practice test and the homework is due next class?
the practice test on paper is not due. You don't need to submit that.
Oh, I thought you was talking about WebAssign. Sorry.
Paper sign, I'm trying to put one in. So if I do that, then that will not be due next class. You'll have more time for that. But
Also, Professor,
Wait,
in the
Professor, where's
worksheet,
the
it shows
practice
that we have
test?
applications. Are we not going to go over that?
okay, one more time. Samantha, go ahead.
In the worksheet, we have applications still to go over. Are we not going to go over that?
Yes, these questions, yeah, we are out of time, so I'm going to do that in the next class at the beginning, and I will avoid these problems in the next class. I was going to do all discussions, but I'm going to have to do this in the next class. It's nothing. It's the same as what we just did. They are just verbally described. That's all. But I don't want to take too much of your time. If you don't,
Professor, will the practice test be on WebAssign?
I'm sorry.
Will the practice test be on WebAssign?
That's what I'm going to place a practice test on WebAssign. And if I place that, if I do that, I'm trying to work on it. I don't have one ready. So if I make that, it will be due Monday, not this Wednesday. Okay.
Yeah, okay.
All right. There's only one assignment today. That's due Wednesday.
All right, take care, Professor.
You too.
Have a good day, Professor.
You too. Have a nice day. If you have questions, hang around. Otherwise, you're done.